with that, I need to now step into the, let's go into the word from our sponsors from Avinash from Xilinx. Avinash, are you there?
Yes, I am.
Brilliant. Talk to us a little bit about your company for 2 minutes, for no more than 2 minutes, and then we can get into the panel. Tim, take it straight on from there.
Yeah, thanks a lot, Dom. Yeah. As we all know, live video streaming has become a critical business need, right? And video service providers everywhere, they're faced with the challenge of delivering high quality user experiences at the same time while managing their infrastructure and operating costs. Now, given this computational intensity of converting video, transcoding has prompted the need for an adaptable hardware acceleration platform. And Xilinx real-time video server architectures, powered by Alveo accelerated cards, they help to deliver high quality video performance at the lowest cost per channel, resulting in significant total cost of operations savings for video service providers everywhere without altering their existing infrastructure. Xilinx solutions are up to 5 times faster than generic processors. They're up to 6 times lower in cost, and they consume up to 5 times lower power. And as part of the Alveo series, Xilinx now offers the U30 high density transcoder, which is a single slot, half height, half length PCIe card capable of up to 2 4K P60 transcodes or a variety of resolutions, as many as up to 48 540 P30 transcodes. With support for both H.264 and HEVC encode, this is a very highly efficient 25-watt low power solution in a great form factor. And we're now excited to launch the complete SDK for this with FFmpeg, GStreamer, and XMA support as early as next month. Do check out our Xilinx web link for any information, or feel free to reach out to me. Thank you.
Avinash, thank you very much for that. And that is a beautiful segue from what we were talking about before with power and efficiency. So we've also got Erin and Ian on. And Erin, I'm going to let you go first just to make sure we've got audio and video from your side.
Okay, let's turn it on. Can you see me?
There you go. How are you doing today?
I'm good.
Good, awesome. And Ian, you're out there as well?
Yeah, I'm definitely here, Tim.
Okay, fantastic. So I'm going to just throw a question out. Why the industry's sort of been moving from software to hardware, and this is a bit of an anomaly because in the old days, it used to be we tried to move, to software so we could make modifications and like that. So Ian, from your standpoint, why this move from software to hardware?
I think that a number of reasons, and actually picking up on what Vinay just said, it's interesting that everybody's looking to do the greening of streaming, all those good things, but the world has changed dramatically from VOD content to live content. I mean, VOD content, you can use software, you can take a lot of time to get the best video quality you want, and latency is not a problem. But when you've got live, latency is an issue, and this is where you need to go to hardware, and this is why we've seen this transition from software through GPUs, FPGAs, and our story at NETINT is that an ASIC is the answer. And I mean, Avinash very clearly explained why an FPGA is very, very efficient. But then you take the next step, and an ASIC is actually 5 times more efficient and 10 times less power. It's just driving it from what was a very logical software solution into hardware these days, and specifically ASICs.
Okay, and we'll come back actually to that power efficiency. Let me throw out to Erin. What are some of the trends and requirements that CDN providers have now from a compute standpoint?
Thanks, Tim. Yeah, so from a trend perspective, what we are seeing is there is a peak capacity growth, significant growth in the past years, especially starting from COVID at a rate of 80% year over year. And there's also the demand for encrypted video content following the web content and encryption. So we all know the pricing is getting very competitive as your demand increases. Of course, your infrastructure, your more users, how do you sustain your infrastructure to lower your cost while still maintain the high quality of the video and maintain the infrastructure at a cost, sustain with the demand? So there's challenges comes with the capacity growth peak. We all love the infrastructure growth. At Intel, we love it because we sell hardware and we don't buy. But then the reality is CDN providers don't purchase the way that it doesn't. Your demand increases, but your hardware infrastructure doesn't grow linearly. So the infrastructure challenge is when you build your infrastructure builds on the peak demand, but your on average traffic is only a fraction of your peak traffic. So most of your infrastructure is actually sitting idle. So that's a trend that we're seeing from CDN providers, where we've been asked to help them to optimize how do they deploy additional services on top to utilize additional headroom in the infrastructure. So this is when you start to see some interest in the emerging use cases like augmented reality, 360 video, volumetric video, cloud gaming. Those are very edge sensitive use cases, emerging use cases that the CDN providers are looking to. And there's also creativity in the infrastructure. I think we're seeing from the telco vendors, where you could see some of the traffic actually for average traffic has been allocated on their the next gen central office or the edge data center, where some of the they use the core network or the access points for the peak traffic. And cloud deployments. So it's a lot of, I think we're seeing the transformation of CDN providers, and we're continuing to help our ISV service providers optimize the software on top of the hardware to help them optimize the infrastructure cost.
Now, you mentioned obviously the build out is to peak and looking to figure out what to do with that compute that's between peak and average. Mm-hmm. Over the last year, given the fact that, as you said, 80% year-over-year growth, has that really sort of hyper-focused CDNs on having a conversation about not having to buy too much hardware because they're uncertain whether those peaks will continue? Or is it hyper-focusing them on conversations on let's figure out all those other things we can do with compute as we build out to these higher and higher peak capacities?
I think we're seeing both. So there's definitely a push for compute power on the traditional Xeon bare metal CDN platforms. And there's actually a lot of discussions. I just happen to be managing the CDN and the immersive use cases is accelerators usages. So now the question comes to not just Intel CPU, we get a lot of questions on how do I accelerate some specific workload that support emergent services at the edge with accelerators. So Intel CPU, as we launched late last year, that comes to question. So now it's really kind of a balancing of deploy services between the CPU platform and where you put when you use the accelerators, and how do you balance the peak traffic time managing the offloading when the system sitting idle with average traffic.
Sure, that makes sense. And Avinash, speaking of accelerating, what are some of the challenges that sort of people face with live video encoding, and where do, whether it's general purpose computing, FPGAs, ASICs, where do those hardware pieces come into play in helping to address those live streaming issues?
Sure, Tim. Well, as we know, the biggest challenge with live video is that the codecs themselves are becoming more and more complex, right? So over the last couple of decades, you've seen as we moved from the incumbent H.264 to newer generation codecs like AV1 or VBC, we're looking at getting those 30 to 50% or more savings in bitrate, but at the same time, it has come at the expense of the huge complexity that's involved, right? And typically what happens is in an encoding engine, there's a couple of things that encoders can do, especially given the constraints of a live environment. They have to be able to handle all this computation. So they usually tend to reduce the number of computations they do. For example, they skip certain modes. They do pull some tricks so that they are able to meet those budgetary requirements of time and computations, right? And that usually results in poor visual quality and lower experiences. And in a VOD environment, that may be okay because you have the luxury of time. You have you can do things over and over, so you can reuse certain hardware architectures, right? But in live, everything gets so constrained So the biggest challenge is, the drive that comes from outside in terms of, getting bigger, getting faster. And that in turn, pushes us towards these upcoming codecs, which have huge computational requirements. And that put together with in a live scenario and to be deployed at scale, it's a huge challenge.
Well, and I know even with some of the work I've done in the AV integration space where we deal with uncompressed video, we've had to use FPGAs tied to a 10G5 to be able to move content around a local network. And then immediately when we do that, somebody says, great, can I get that same quality out there on a stream? And the answer is, sure, if I had all the time in the world, you absolutely could, but because it's live, we've got those time constraints. What role does software play? I mean, you mentioned some of these newer AV1, VVC. What role does software play as we're moving into newer codecs? Because clearly those codecs still aren't nearly as optimized as H.264 has become over the 2 decades of work that it's been out there. So how does the software play into that part of it as well?
In general, when these codecs, the evolution stage for these codecs is that you have a software model initially where all these different tool sets are evaluated, and you come up with the best set of tool sets that give you the ultimate quality. And then usually the software is not optimized initially, right? Because you're not ready to deploy it on scale. And the driving factor to towards these newer codecs is usually the visual quality or the savings in bitrate that you can get, right? But over time, as the codec gets more and more deployed, we're looking at deploying it at scale now, which then brings in additional challenges. How can this be optimized? What metrics can be added, right? So there's encoding. From an encoding perspective, there are 2 things. The codec brings in a certain standard, a set of tools that it can define what you can use. But how the encoder uses those tools, it's certainly up to the implementation, right? Every implementation, every encoder out there is different because, yeah, they use the same coding tools, but the way they use it, how they intelligently allocate those bits, which areas in the video they think are complex, all these decisions have to be made by any encoder, and every encoder makes them differently, and that's what it makes it unique. And so software is much easier because there's programmability involved in software, which helps making these decisions faster, right?
So Ian, I know you mentioned the efficiencies of ASICs, and most of the companies I've worked with that have had ASICs have had mature codecs like H.264. How do ASICs play into models with some of these newer codecs as well?
Yeah, actually, I think it's good to have Avinash on the score because he's the encoding expert. Everybody should rush out and buy his book. Can I say Avinash, Decode to Encode? There you go. I don't understand a word of it, honestly. But you have to look at, I think, some of the efficiencies, and Avinash really understands that, what we're trying to achieve. And as you say, the older ASICs, the older codecs H.264, it's been around for 15 plus years now. The advantages of just doing it with an ASIC are that compute power that you're talking about. It's Avinash and I were at a company that was building an ASIC that got acquired by an FPGA company. And look what happened to the FPGA company. It got acquired by a company that makes ASICs. So Intel got Altera, and now AMD's got Xilinx. There's a reason for that, and it really is driving the fact that ASICs are very expensive, very complicated things to build. But once you've built them, once you've got it right, then they are very, very good things to put in the network. And the days, in fact, I was talking to my old boss from 20 years ago, who said we first cut our first ASIC for video 20 years ago. It cost $1 million to build. It's a lot more than that now. But nowadays they come out the fab and they work. You don't have the risks. You don't have the problems associated. It's like satellites launch these days. They don't blow up on the launch pad that often. And so I think a lot of the risk has been taken out. So therefore people are actually happy to go ahead and build them, which is why you're starting to see not just me and my competitors, but also my customers building their own ASICs. You're seeing that very much in the silicon world these days.
Well, and having been in the streaming industry for almost 24 years now, it does seem we hit these waves where somebody says, okay, we're going to spin silicon because we've got a mature codec or we have feature sets that we want to make sure are in there for the efficiencies, exactly as you describe. Erin, from a general purpose computing standpoint, and obviously understanding you own more than just CPUs, you get GPUs, and even as Ian alluded, you have FPGAs. What's the role of software for the CDN? I mean, sort of beyond the codec.
Yeah, so we know that, and as we can see, 400 gigabyte Ethernet upgrade cycle is finally here. The 200 gig and 400 gig switches, based on the market data, is actually going to be represent about 50% of the overall data center revenue by end of next year. That's a very impressive number. Now, what does this mean is, as I mentioned, the challenges for the hardware. So software actually really play a critical role in optimizing these hardware platforms on top. It really takes a solution of hardware, software, including all the components you talk about, the CPU, the GPU, and Intel has FPGA, and even the connectivity component as well, all together, and even SSD. Actually, SSD is a big part of the platform as well. And having software on top, because CD is predominant storage and network workload. So there is actually a lot of room that we can tighten the performance on both the hardware all together. When we look at it, it's really, we're trying to look at work with our ecosystem partners, look at it from a end CDN provider's lens of view, is how do we provide the solution that we can optimize at a CDN deployment level, where it's bare metal, or at a deployment for a different services, whether it's emerging services. So we provide for example, like we work with OEM partners, and we pre-configure some of the system configuration based on some of the latest CPU before the launches, and we actually pre-test a lot of the CDN stack, software stack, work with the CDN vendors, so it's customer market ready by the time it launches for them. And we also learned that actually for CDN, it is a lot of proprietary stack. So customization is very important in software. We have to work with the software vendors to tailor the software to be how their applications need it, versus just provide a generic software framework. At least for now, it doesn't really scale that way for software in the CDN space.
Okay, that makes sense. So Avinash, with all these new codecs, of course, comes the resurgence of transcoding. I mean, with 264, you did transmuxing, transrating. You didn't really do a lot of transcoding. Now, all of a sudden, if we're faced with AV1, H.265, H.264, VVC, EVC, SP, et cetera, what are some of the transcoding issues and scenarios that CDNs are going to face?
Well, the biggest thing is in the encoding engine itself, right? The reason the encoding engine is complex is because it has a combination of both math, the intense math, for example, transform operations, and then motion comp, those kind of computations that are fixed, but they have to be done over and over. Plus, encoders have to take, like I said, decisions on which areas in the video are better, and how do they allocate those bits to those areas as opposed to others where the quality does not matter a lot. So the combination of these pose a huge constraint on the encoders. To give you an example, a 32 by 32 pixel transform will take up to for a 1080p60 live video will take up to 2 trillion multiplication operations per second, right? So when you put this all together, the complexity, and given the constraints of live video, right? So transcoding faces severe constraints to be done for these newer codecs just on software alone, right? So if you have like a WAD scenario like what Ian mentioned, software only could work, right? But on the other hand, when you have the volumes that we're speaking of, the newer codecs, and coupled with the the higher resolutions and whatnot, hardware solutions, initially you could start off with an FPGA. where you get the flexibility of software programmability coupled with some hardware acceleration. And then as you grow in scale for transcoding, you move towards ASICs, right? Because ASICs will give you the efficiency. Even you have tried and tested your algorithms, so you know what works, how to get the best bang for the bucks in terms of quality for the bits. And then they give you the best power consumption. It's a low cost solution. It can be deployed at scale, and it could be improvised over time, right? In ASICs today that are deployed for H.264, there are ASICs running for like 15 years. And the quality of ASIC, the same ASIC deployed, let's say a decade ago, the video quality back then would have far improved because there's programmability built in on top of ASICs, and they keep improving it all the time. Of course, it's not possible to, add a new generation codec, but with the same codec, say today you deploy AV1, 10 years down the road, the same ASIC, the quality could be significantly improved, provided you have the right architectures for it.
Yeah, and I've actually worked on ASICs 20 years ago that are still running quite well, in controlled environments. So you're absolutely right from a longevity standpoint. In AV1 has been mentioned a couple times. Talk about AV1 and sort of some of the potential benefits there, both from an ASIC standpoint, but also just the codec itself.
Yeah, in fact, if you want to talk about the codec itself, then you need to go back to Avinash there. But he really struck on a lot of the things that are issues. It's the complexity of the video that's going on at the moment, and we've got to look at how we're consuming video and how that's changed. AV1 is going to be very, very powerful with mobile devices, handheld devices, and into the live streaming out into the wide world where we're all carrying this little rectangular thing around and watching video. The compute that's needed to do that, you're taking the decode, you're taking the effort away so you can actually do high quality video in your device, and the battery will run and you don't cook your hand while you're watching it. But the problem is the mathematics has to be done somewhere. So it ends up getting done at the encoder level. And I always say that it doesn't help if you can use the same device to cook popcorn and encode a movie. It just really is very, very inefficient. And so AV1 is going to provide all kinds of flexibility. I mean, we're seeing around the world all kinds of different applications that are being used, cloud mobile gaming, for instance, VDI, video desktop. AV1, once it gets adopted and widely deployed, is going to be it's going to dramatically change the industry that we're in. At the moment, though, we don't have the billions of devices that are out there that can decode like we can do with 264, 265, and so on.
Mm. Well, and as you say, whether the DCT is done at the encoding side where the heavy math is, and if the decode is lighter, that seems to be one of the benefits of AV1 is the decode side is much lighter than the way 264 works. Erin, last question for you. You mentioned web accelerators at the edge. Talk a little bit more about that, because I think that's important as we begin having conversations around edge compute to understand sort of where accelerators play in that.
Yeah, so edge accelerators, as I mentioned, is new to us, but it's the area that we are continuing to look at. What is requirement? I think it's a little different from the traditional data center and for CD. And at the edge, what's important is scalability and density, where you have codec processing, that software flexibility of high quality video is always needed. But at the edge, especially when we are talking about some of the emerging use cases, the augmented reality, 360 video, even cloud gaming for mobile phone gaming, those are extremely sensitive, and it's only made possible on 5G deployments at the edge. So the accelerators really, and I touched a little bit, is where we see is where you need high quality video is still traditionally CD and on the CPU platforms. But when there's a need in the industry for driving multiple, and it's still emerging, so there's a lot of video services that's unclear, but I don't want to dedicate a platform just for one services, you need the flexibility and acceleration at the edge to support multiple services. So I think the edge deployment accelerator would actually support the hardware role where you can deploy things in a more cloud native microservices way for support in conjunction with the software. So a lot of the really latency sensitive use cases can be made possible at edge now, like esports. Stadium is a really good example that you have augmented reality or 360 view of the stadium that usually takes days or a few minutes of content will take a day to process. And now you can actually do it in real time and process at the edge, probably a server in a stadium that can actually be viewed. It's all possible with 5G. So I think with 5G enablement, we will see a lot of the emerging use cases. Edge compute has become more important. Accelerator really plays a hardware acceleration role versus pure software.
Okay, very good. Thank you. That's a very good explanation. And then Avinash, finally to you. I mean, you mentioned at the top of the half hour that there's these new products that are coming out with the focus. Where do you see the trends in both pure processing and power consumption going over the next 18 months? We've gone through this massive uptick in consumption of media in the way that we all like to see it consumed. Where are we going forward from this?
Yeah, primarily, like I said, we're moving towards everything that is bigger, faster, better, and more secure, right? Like we need those high definition 4K or 8K. We prefer that now. And we need to be doing things faster, which means higher frame rates, lower latency. That's one key area where things are being driven towards. We need things better, meaning you want that HDR quality when you have that 4K. You want 10 bits. You need all these fancy tools, and sooner these are not just stuff that is lying around there. They become necessities as part of your toolkit, right? As they gain adoption. Now, so to be able to do all this at scale, at Xilinx, what started off initially as an FPGA only hub, we're leaning towards, getting to a place where you have, hardened solutions like ASIC IPs, right? So FPGAs to start with, to cater a certain class, but when it comes to at scale, especially a very low power, for example, in an edge compute environment where latency is of the essence, and you have to deliver very low cost solutions. If there's a proven standard that can deploy that, and you better have an ASIC out there that can serve people at scale, right? So we're moving towards finding that good sweet spot of balance with a high quality solution that an FPGA can offer and a high density solution that an ASIC can offer, right, to meet all these requirements at scale. So that's where we're kind of headed, over the next year or two.
Well said. Awesome. Thank you very much to the panel. Dom, I'm going to hand it back over to you.
That was awesome. As always, I'm still feeling like I've been out running. I'm halfway through a marathon already. Not that I've ever actually run a marathon.
Just don't add a Red Bull to those coffees, please. I know you.
Those that know me will probably be laughing at this stage, thinking of me running a marathon. Anyway, Avinash, Erin, Ian, thank you so much for the panel. Tim, thank you for hosting. That was an awesome panel and a great segue from this morning.